So, when it comes to related rates problems, this video is going to discuss how to set them up and how to evaluate them as well. Now, first thing for any good problem is the ability to identify what kind of problem we're working on. Now, to identify a related rates problem, you are going to be asked a question about a rate. So you could be asked questions about how fast or at what rate or something to that tune. Additionally, somewhere in the problem, you'll be given another rate. So we'll say you'll be given at least one other rate. Sometimes you'll be given two or more rates, and that's fine. We're still going to relate them together. Now, once you identify something as a related rates problem, there is a 5-step procedure that we're going to go through that has a really unfortunate acronym. And the acronym that we have for this is DRIPS. It's really not as bad as it sounds. D stands for define variables relevant to the problem. None of the variables that you should define should be rates of change. Rather, if you are asked about something whose rate is changing, then you would want to define what the original quantity is. So we could say what quantities in the problem are changing. Additionally, it'll be important to identify some things that are not changing, and we'll identify those as constants. The R of DRIPS is going to be to relate the variables. Do the variables form a right triangle? Do they form some other geometric figure? Ultimately, you are going to have to come up with some sort of relation for those variables. This is an equation containing all relevant variables, as well as maybe some other constants that show up in the problem. The I of DRIPS is going to be implicitly differentiate with respect to t. Now, what this will do once you implicitly differentiate with respect to t, and we saw this in the last video, this will introduce rates that are now related. Therefore, you are dealing with a related rates style problem. The P of DRIPS stands for plug in any known rates or instantaneous quantities. An instantaneous quantity is something that does change, but you're given a value of it at a particular moment in time. So instantaneous quantities should not be plugged in until after you've implicitly differentiated with respect to time. And finally, the S of DRIPS is going to be solve for the desired rate or other quantity. So DRIPS, define, relate, implicitly differentiate, plug in, and solve. I will demonstrate this in the next couple of videos.